right, let's get started. Thanks for coming. We're going to talk about Java 9. We're going to talk about a few key parts. Java 9 itself is one of the most powerful improvements to the language. We'll talk a little bit about that, and then we'll focus on what we're going to talk about in this presentation. Well, looking back in time, over the past few decades, Java had been very stagnant and not very many improvements over the years, and suddenly all that changed with Java 8. If you really look at Java 8 itself, you could say Java 8 was somewhat of an opt-in to a certain extent. As a programmer, you had the choice of saying, I want to adopt these things, or I want to wait out and maybe adopt later on. While Java 8 was extremely significant from the programmer point of view, Java 9 is significant from every single person point of view. It doesn't matter what part of Java ecosystem you are dealing with, there's going to be an impact related to it. And that is one of the really interesting things about Java 9 is it is probably, we could claim, the most significant change to Java ever, even more than Java 8 itself in that regard. So I want to talk about Java 9, and there's, if we can come up with a laundry list of all the features in there. And a lot of times there are two problems with such an approach. One is the list is very big. And the second problem is we don't remember any of those when we just look at a laundry list of features. So I step back and ask the question, what do I want to really talk about in Java 9? And I realized that there is actually 3 different groups we can look into when it comes to Java 9. So I decided to classify what we're going to look at into 3 different groups. The first one, I want to put them into a category called improvements and changes. What I mean by improvement and changes is these are things you already do in Java 7 or Java 8, but you can do it a little bit better. And that is always nice because, hey, whatever I'm doing before, I can do it a little bit better. That makes me more productive. That's awesome. So we're going to look at a few things that I would like to call as improvements and changes. The second category is what I would like to call as additions. Additions are things that did not exist before, but we can use them now, and as a result, benefit from some of those things that are available. So I'll call them as additions. And the third category, I was kind of wondering what to call it. So very politely, I decided to call it as advances, meaning disruptions. It's going to hurt you, going to kick and you can scream, and then eventually we come out ahead, enjoying it. So that's what I want to talk about, these 3 groups in the next about 3 hours or so we have together. I want to talk about these 3 different things. So let's get started with the first category here, improvements and changes. Let's talk about interfaces. Well, in Java, of course, we've had interfaces from day one, which is one of the things that really excited me. I came from the background of programming in C++ years ago. And when it comes to C++, we had abstract classes. We could have, abstract classes with pure virtual methods. But the concept of interfaces never sunk into me. And I remember the day I got, I looked at Java's interfaces and interface inheritance. That's an unforgettable moment in my life. I still remember that after these many decades, because that really changed the way I look at the language and how I can use it. So interfaces have a special heart in my mind. So we could call an interface here called util, let's say. And in this case, the interface, let's say, has a method I want to write. In this case, we'll say it's called get, let's say, number of cores, for example. Well, I want to know how the compiler deals with this, so I'm going to output right here just the word OK. And you can see that the compiler is pretty happy with what I wrote, so no big deal. It seems to be, hey, you're happy, you're writing Java, I'm in good terms with you. But if I go here and try to implement this method, maybe I say return 4, for example, immediately Java will give me an error, obviously saying, what are you trying to do? Do you know Java? It says. Well, obviously we cannot put implementations into interface, or at least that's the way it used to be. So my definition of interface in Java was an interface, and where an interface is something that told a lot about what it'll do, but it never does anything. Kind of like my boss, I always say that. So that's basically what it was. But this has improved quite a bit, thankfully. Now we can write implementations, but we can put a default method in it in Java 8, of course. So we can create these as default methods. That's really nice. But let's step back for a second. Let's talk about classes. Well, when it comes to classes, you normally write public methods in classes, but occasionally you will realize quickly that multiple public methods require the same implementations, and rather than duplicating that implementation, because we know that if we start duplicating things, we're in violation of the dry principle. So rather than duplicating that implementation, we say we want to really reuse that function. So what do you normally do in a case of a class? Well, you will take that common implementation and roll it into a private method within classes. The same concerns appear here as well with interfaces. It's quite possible that multiple methods, default methods in an interface, may have common code. And if there's a common code, where would you put it? Well, you could roll them into another default method. That's one option. But if you roll it into a default method, that method you rolled into from other sub-methods become available for inheritance by classes, become available for use. And maybe you're saying, well, I want to roll these methods together, but I don't want you to really use it from the outside. It's for me, for my internal purpose. We call them as helper methods. The same exact idea is available for interfaces too. So for example, if I wanted to really call this as a helper, and whatever the helper is going to return, I'm going to return from here, I can say private int helper. In this case, let's just return that 4 right here, which I wanted to really maybe reuse in other methods. I can definitely do that as well. But because this is a private method, it is hidden within this particular interface, not available, not visible, and so that is one of the things. Now, of course, you know that you can not only put a static method in an interface, you can also, a default method in an interface, you can also put static methods also. So for example, I have some method foo here that is going to be a static method. Well, in this example, of course, you may wonder, if I have static methods and default methods, what's next? Do I have private methods? Well, they say be careful what you wish for, so you actually do have that now. You can have private methods. But what if I want to really share this method within a default method versus a static method? How would I actually use it? Well, if you have a method which is going to be used within a static method, we'll say in this case helper2, well, obviously I want to use helper2 within the static method. So I could say private, let's say int helper2, and let's say in this case I want to return the value of 5. But unfortunately, though, in this case, we don't know what that means, so we get a little compilation error saying I cannot reference the helper2 from a static scope. Well, obviously, in this case, you would say static right here, and then that would be calling that. Well, that begs the question, do I really need to say default over here? Because after all, this is for a default method versus this is for a static method. And the answer is no, you cannot. So if you want to really write a private method which is for access by default, then just write as a private method. If you want a private method that's useful for static context, then do sprinkle the word static in along with it as well. And so as a result, you can write private methods in interfaces too. And essentially, these are for helper methods that you're going to write, and then tuck them away, and so you can reuse them across multiple methods as you may choose to. So that's one nice little improvement in the language, where you can have these reusable methods you can provide really nicely, and that's basically what you have available. One other little improvement goes back to Java 7 feature. So for example, if you have a class called resource, let's say, and I have a constructor for resource. In this case, I'm going to just output, let's say, created right now. And then, of course, I want to implement, let's say, a method. We'll call this as op1. And all that this op1 method is going to do simply is, let's say, output op1. Well, that's my little resource class. But I want to implement a fairly good cleanup of this resource. So what you could do in this case is, in the class, of course, you can write a public void close. And the close method simply is going to say, in this implementation, all I'm going to do is clean up. Well, okay, so that's a cleanup method I have implemented. But I want to use this resource class and make sure that it is going to perform a proper cleanup operation. How do I go about doing this? Well, rather than having to spend the time and effort doing this, we could simply say implements, for example, and you could say auto-closable. And auto-closable, of course, expects a public close method to be available. But the benefit that gives you is you can put a try block and say resource, and then once you create a resource object right here, you can say equal to new resource. You can go ahead and call the methods you want to call. For example, in this case, you could call resource.op1. But when you nicely leave the block of code, right here, the close is going to happen for you automatically without you having to put any effort. We call this the try with resource, or ARM, or automatic resource management. Well, this worked really well. There was one small edge case, if you will. This really required that this object that you are putting around as a resource constraint is being born right there in this call. Well, that is really a good idea most of the time. There may be a time when you acquire this object from somewhere else, or even different. What if this object is passed to you in your function call? Well, you may ask, why would you really bother about it? Well, remember that two-letter word we all occasionally think about, DI, dependency inversion or injection. So if you have a dependency injection, you want to be able to receive that being given to you rather than you calling a getter to get to it. So how do you deal with dependency injection? Well, in the case of dependency injection, maybe I have a function, you're passing this as a parameter to my function, in which case this object is not being created right here, so it's going to be available outside of this. Maybe it is coming from somewhere else, like a parameter to a function. Of course, I'm creating this right here, but silly me, but it could be coming in as a parameter or somewhere. But you do want to put a constraint around this resource and say, you know what, you created it, you're giving it to me, but I'm the owner of this object. Well, that restriction of the try with resource has been removed now. You can put that outside, so it could be given to you. I do want to mention that I'm always wondering whether this is a feature or a flaw, because this could be really misused as well. So I would use it with a grain of salt. If you really have a good reason to do this, then use it. If you're not very convinced it's a good idea, usually I ask for help. I go to a colleague and say, I have these evil thoughts in my mind, can you review my code? And usually they set me right. So the thing is that don't assume this is actually a good thing. It might be good in some special cases. A lot of other times, this might not be a really good thing. One of the reasons we have to be careful about this is, while the object is being cleaned up, you notice that it is calling the cleanup right there, and I'm going to say done over here. Notice that done came after the cleanup, but the object is still available to us, which can really be problematic if you're not very careful about it. So use that with a grain of salt. Don't just assume that because you can do it, that you should actually do it. So that is just a feature, and I think it's useful. Like I said, I can think of a few different reasons why this is good. DI is one of the reasons I can think of, but again, use your judgment whether you should use this or not. Well, moving a little forward, let's talk a little bit about what a few other languages normally do. Well, if you look at languages like Groovy or Kotlin, in these languages, when you have a parameter coming in as a lambda's parameter, you can receive the lambda and you can give a name like E and you can print the value of E like this. But programmers sometimes do some other things, like they say K and then print line K. And then somebody else says, L and then print line L. And I've come to the point where I realize these variable names are absolutely random. And one day I was working with the code, and I was trying to predict what the next variable name is going to be. And I totally failed at it. It was that random. And then I figured out, finally, the way these variable names are given is programmers don't actually type this. They are coding away, they get distracted, and they look around. Their cat literally walks on the keyboard. And whatever key they step on become the variable name. And they love their cat so much. They say, oh, wonderful, you gave me a good variable name. Now go play while I continue to code. And they just code away. Well, if you're going to come up with absolute ridiculous random names, I would rather get rid of the ridiculous names and let the language take over. So in these languages, what we can do really is, rather than writing these ridiculous names, we can simply get rid of it, and we could say it, for example. And in this, of course, the it stands for, the first and the only parameter that's coming in. On the other hand, if you look at language like Scala, you would similarly write a lambda, But in this case, you may potentially get multiple parameters, but you use an underscore for that. In fact, in the case of Scala, you could even use underscore multiple times. And in this case, you could even do something like that, if that makes sense in the context. And this would be where you're receiving one, but not one, but two arguments to the language, to the lambda. I have to say the jury is still out on it. I've only seen two kinds of Scala programmers. Those who love this and those who hate this. There is nobody in between, I think. So, and it turns out the people who hate it are more than the people who love it also. So this is a little hard for programmers to get used to it. But Java is still not sure. In the case of Java, the jury is still out. I think they're sitting there and debating, a group of people saying this is awesome, and the other group saying, are you out of your mind? So they want to take the time to decide. While they take the time to decide whether they want to do something like this in Java or not, they wanted to take a dibs on that variable. So in Java 8, the underscore was made as a warning. So if you had a code where you used underscore, you'll get a warning in Java 8, but now that turns into an error in Java 9. So for example, if I said equal to 4 right here, and then if I wanted to put the output. Now, why in the first place I used an underscore for defining 4? Because we can all agree that makes the code so much more readable, isn't it? So as a result, we want to use these kinds of beautiful syntax. So, but when I run this code, you notice it gives you an error. It says release 9, underscore is a keyword and may not be used as an identifier, and so they don't want to use it. So what is the answer? The other day I was talking to a programmer, and he was quite content with it. He said, hey, that's not a problem. If they will not allow me to use underscore, I'll use 2 of them. Like, no. So this is not a good idea. And the next thing you know, there are programmers doing this, and old guys like me have a really hard trouble, because now I have to start counting the number of underscores. I mean, if your goal is to make your code unreadable, I mean, there are several ways to do it. Still don't use this means. So the point really is, this is not a good idea. And clearly in this case, you can see that the language doesn't really bother if you do this, but the rest of us should really do that. And why did I put console.log? Bad things happen when you do that. Okay, so you can see that it's the real output right there, and I'm going to even try to put that in there and see that's, okay, so don't go there, definitely. So the point really is that underscore is no longer available, and so what is the answer? The answer is give it a respectable name for it. Whatever that meant, give a good name for it, and then use that name and be happy with it. No need to make the code really cryptic after all. So no underscore. Well, that's great so far, but let's talk about Java 8 one more time. Well, in Java 8, I absolutely have to tell you that I love streams. You probably know this already. I just enjoy using streams. But when it comes to streams, let's say we have a collection of values to work with. So in this case, I'm going to say integer, we'll call it as numbers, is equal to arrays.asList. And in this case, we'll say I have 11, I have a 32, let's say a 12, maybe a 54, maybe a 67 and 81, and then a 16, and then let's say 12. All right, a 15. Well, maybe what I want to do is I'm going to say print only values greater than, let's say, 55. Well, how would I print only values greater than 55? I can say numbers.stream, and then I could say filter given an element greater than 55, and then I could say for each and system.out, and I can simply ask it to print that value. Well, while that's really easy to do, what really happens in the case is the filter operation. It gave us the 67, it gave us the 81. It did not give us anything afterwards because those are not really greater than 55, but it picked up every single value and decided whether to take it or not. So here's a way you can think of a filter. Think of a filter as a flap which will be doing this back and forth, back and forth. So a flap may open and close and open and close. It may stay open for a little bit, close for a little bit. It can go back and forth. So a filter is like a flap. So when an object comes in, it can either let it go, or when an object comes in, it may block that object and drop it, and then maybe let the next value go through or block the next one. It can go back and forth. This has been around in Java 8, which is really nice, but there is one deficiency in Java 8, however. Well, what is the deficiency? Let's step back for a second. In the case of this one, we had a method called limit, and the limit will tell you how many values go through. So I can say limit 2, for example. If I said limit 2, it only allows me to let 2 values go through. This is already in Java 8. Similarly, there's a method called skip. And the skip method will remove 2 values and let the other values go through. Notice it started with 12 because we skipped 2 things. Again, that's available in Java 8. So Java 8 gave us methods like filter, and then on the other hand, methods like limit, and the methods like skip. While if you look at this, there's a disparity here. If you looked at the filter, what did the filter do? The filter took a predicate. And that's basically how the filter worked. It took a predicate. On the other hand, unfortunately, limit took a count, and the skip took a count also, a number. Well, wait a minute though. What if I want to limit not on a fixed number, but what I want to limit based on a condition? So in other words, if I want to say, go ahead and keep bringing values for me, but the minute you see a value that doesn't meet your condition, turn off the switch and stay turned off. So the way this limit can work is it'll stay open, but when a condition is met, it closes and never to open again. That would be really cool, isn't it? Well, one way to have done that is we could have said limit while. But if they called it limit while, they would have been consistent with limit. And in software development, we should never be consistent. So they said, we'll call it take while, because that's so much better. So we'll call it take while. And in this case, we will say, given an element, we'll say element is less than 55. Well, notice in this case, we're going to take less than 55. So this is going to be less than 55, less than 55. We keep going, but 67 is not less than 55. Turn off the switch, close the gate, never letting anything go after this. So the last member is going to be 54, and nothing after would ever show up because you close the gate, shut the door, and went away. So that is take while. Similarly, remember you have a skip over here with, let's say, value of 4. This will drop the 4 values or skip the 4 values and then give you all the other values starting from 67. Likewise, you have what is called a skip while, but they could not call it skip while because they'll be punished for being consistent, so they called it drop while. That's really, really nice. So in this case, you say given a value e less than 55, well, drop everything less than 55 and bring everything else after that. So that is basically the take while and drop while, which are the cousins of limit and skip, except that they are condition-based rather than a fixed value-based. I do have to tell you that I'm really happy for these functions because there are a lot of times I would be writing code in streams and I would suddenly realize, oh my gosh, I want to break out of my loop, but there's no real good way to break out of the loop. And that becomes really hard. This gives a nice way to break out of your loop or to continue at the proper point. So in other words, take while and drop while are really your continue and break equivalents in imperative style of programming, where take while is equivalent to break and skip while or drop while is equivalent to continue. So these are extremely important functions that make our life a lot easier. Without these, it was really hard to program with the functional style, and I'm really glad that that's been added to the language. So definitely a really good welcome addition to the language. So this is another improvement we talked about. Now, the next thing I want to talk about here is when I talk to people who are doing imperative style of programming, I often encourage them to move towards a more functional style of programming. So this is Java 8 again one more time. Java 9 introduced take while and drop while. But in this case, going back to Java 8, I can do the following. I can say for int I equal to 0, I less than 5, I plus plus, and then I can simply output I right here. Well, in this case, as you can see, that's a traditional for loop we wrote. Well, the equivalent of this in Java 8 is, I can take this one and say, I want to use a stream. In this case, we would say int stream into stream.range from 0 through 5, and then I could say over here for each, and in the each, of course, we'll simply say system.out, and we will go ahead and print out this particular value from our expression. Well, the output is exactly the same as the other one. Well, this is a much more civilized way of writing this. This is in Java 8 already. But what if I had a less than or equal to in the case of a traditional for loop? If you had a less than or equal to, this will be range closed rather than being range itself. So range closed will include the last value, whereas range will not. So if you put a range, it stops one shy. If you put a range closed, it also includes that value. Maybe you are helping a colleague of yours who writes program in imperative style and eats imperative style for breakfast, and you're trying to convince your colleague to start writing code in this style. But you know how sometimes people are not really that convinced. And your colleague comes to you and says, oh yeah? So how do you do the following, I equal to I plus 2? And you're going to say you win and you're going to walk away. Because in Java 8, this is not really easy to do. And even if you try to do this after you're done, you will still have to face your colleagues. That's not going to be really fun at all. So you kind of say, yeah, you're right. Go be happy, write in imperative style. Well, thankfully, that has changed in Java 9. Before I talk about Java 9, I want to just quickly remind you, stream.iterate is available already in Java 8. Stream iterate in Java 8 will take an initial value, and then after that, it will take a lambda, which will keep on producing the next value in the chain, whatever that you want to do. So this iterate is already available in Java 8. But in Java 9, you have something even better. So in Java 9, you can say int stream. And before I talk about this iterate method, I want to emphasize one thing. I'm a huge fan of APIs that are intuitive. I really love APIs that are intuitive, because when an API is intuitive, I quietly, calmly sit down and program. When an API is not intuitive, I'm forced to read the documentation. And a lot of times the documentation only irritates me even further. I want really things to be absolutely clear when I look at it. So let's talk about how clear and simple this could be. When you look at this, this is an initial value that we call as a seed value, so you put a 0. Now, take a look at this closely for a second. What are we doing? Given a value I, you are telling whether you have hit the limit or you have not hit the limit. In other words, the result of the highlighted piece of code is a true or a false. Ta-da, we know exactly what that is in functional style. In the function package, that's called a predicate. Well, there you go. You figured out what you really need. That's a predicate. So given a variable I, tell me I is less than or equal to 5, that becomes your predicate. And as a result, you turn that little Boolean expression into a predicate lambda expression in your iterate method. Then you take a look at this part right here. What does that look like? Given a value, you return yet another value, and you know exactly what that is. That's called the functional interface. Ta-da, that's exactly what we're going to use, a function. So you simply say, given an I want to return an I plus 2. So you replace the equals with a dash, and you got what you really want. And then you say dot for each. And then, of course, in this case, system.out, and then println. I really appreciate what they have done here is they made the code so easy to understand and intuitive. So this is an example of how you can do a looping with the iterate, and that makes the life a lot easier. Well, and while we are on this topic, there is one small improvement you can also do. You know that this part is extremely critical. Sometimes you may increment, sometimes you may decrement, sometimes you may step over by 7, sometimes you may decrement by 4. Whatever you do, it's perfectly fine. You can do a +3 if you wanted to, or a minus 2, and so on. You can do that. However, you also notice that in this case, this actually is already done in Java, and you don't have to put it right here. So what you could do is you can remove this. So in other words, the iterate is overloaded. So the iterate is overloaded where you specify a seed value all the time. Then you specify either a predicate and a function or just a function. If you want to only give a function, then replace this with a limit. And in this case, of course, you can put a limit on it. Or you can also replace this with the other cousin of limit, which is take while. Or you can use a skip or a drop while. You can put all those combinations of things depending on what you want to do. And so drop while and so on. So you can use those flavors as well. So either use iterate with 3 arguments, where the first argument is a seed, the second is a predicate, a third is a function, or use iterate with 2 arguments, where the seed and the function, and then use something to limit or put bounds on your infinite stream, like a limit or a take while or a skip or a drop while, and that way you can control the looping in the way you want to. So that gives you a nice little flavor as to what you want to do. So that is basically an improvement to the int stream. You can use it without bounds, or you can use it with bounds as well. And as you saw here, the bounds is optional. Oh, talking about optional. Let's talk about this other optional that's available in Java. Well, what is optional? Let's step back to Java 8 again. Well, remember effective Java. What does effective Java tell us about this? If you want to return a collection, but you have nothing to return, then, well, return an empty collection and not null. So null is a smell. We want to avoid null as much as we can. And, you don't want to return a null pointer. Null pointers poke people. They don't really have fun programming with it. So you don't want to just return a null, just return an empty collection. That's what effective Java said. And I think most of us have been following this really nicely. But what does effective Java say? If you want to return an object, but you have nothing really to return, then return, what? Null. Well, unfortunately, that's what we've been doing, right? You return a null, and that's no fun. You get into a null pointer exception. What is wrong with null pointer exception? If you don't handle it, it blows up. If you handle it, the code begins to really smell bad. And so there's no real good answer. You get beaten either way you go. You're doomed if you do, and you're doomed if you don't. So wouldn't it be nice to have a compile time error to tell you need to really maybe check for non-existence of value? That's exactly what is available in Java 8 with optional. So as a result, we can take a list of numbers here, for example, numbers.stream, and I'm going to say .filter, give me an element greater than 5, but find first value for me. So what does the find first to say? The find first is very defensive. The find first says, you know what, I may not have a first element, period. The given collection may be empty, or the given collection may not have any number greater than 5. In that case, sorry, I don't have an answer for you. So in this case, if you run this, notice you got an optional 6. On the other hand, if you said 50, because there's no value greater than 50, the first element that's greater than 50 is optional, empty, as you can see. So this already worked in Java 8, which was really nice, but unfortunately, optional had a very many rough edges. So when you picked up optional, there were a few things that you always said, yeah, these could be really better. Let's talk about a few rough edges. The first question is, how do you get the value out of the optional? Well, one way to get the value out of the optional is to use the get method. If you use a get method, it gives you the value 6. But unfortunately, if the optional were empty, what is get going to do? Get will blow up on your face. And that's no fun at all. In fact, you look at this and say, wow, isn't that what I tried to avoid in the first place? So if you go to the people who wrote this method, they will tell you if they had a time machine, they will go back and remove this. And this is one of the most terrible methods in the JDK. So I have a best practice recommendation for you. The best thing I would like for you to do with get is forget. So don't even bother it. Never use it. Not a good idea. So, well, then what could I do? You could use an or else and then substitute a value for it if you want to. Okay, that was there already. We could use that. But let's talk about other ways to process an empty versus non-empty optional. Well, let's go ahead and save this away so we can easily talk about it. So let's say optional integer over here, and we'll call this as first is equal to, and we'll just save this away into this optional. Now that I've saved into an optional, you could have said first dot over here, first dot is present, and then you could do some work with it. So if it is present, you could do this. If it is not present, you could maybe say something else about it, saying that it's not present. So that's one way to deal with it. While that worked really well, that's still an imperative style of code, and you don't want to really do that. Okay, strike that. Here's another alternative you could have done. You could have made this a little bit more functional. You could have said first dot if present. How nice that is. And then you can say, given a value, I want to output the value E. So this works really nicely. But the problem is, what if the value doesn't exist? You are kind of left in a no man's land. Well, how do I deal with it? And you kind of sit there and scratch your head. Well, there's no way to put a not operation on this. So it kind of feels a little weird. You have to maybe go back to the imperative style. After all, that is not very pleasant. And maybe one day you sat there and said, wouldn't it be so cool to have if present or else? Well, why not? So you have an if present or else method you could actually use, and you can imagine what this is going to look like. This is going to take a if part, but it's also going to take an else part. And as you would imagine, the if part is going to take a value and do something with it. And we know what that is, something that takes a value and does something with it. That's called a consumer. But we also know something that doesn't take anything and doesn't give you back anything. That is called a runnable. So in this case, you want to just say, I don't want anything. And in this case, I can output whatever I want to output, maybe a word nope over here to say, I don't have anything at all to give you as a response back. Well, in this case, it's if present or else, and I can tell him what to do in the absence of it. So you can see if present or else takes an if part and a nice little else part as well. And you can pass those two parts and deal with it. If the value exists, the if part kicks in. If the value doesn't exist, the else part kicks in. So that is a very nice little addition or improvement to the language JDK API. That's really nice to have. So that is about using the if present or else. But on the other hand, let's step back again and talk about two different functions that behave a little kind of differently. Talk about the map function of the optional. What does the map do? It took me a little while to get a grasp of map. What a map says is, if an optional contains a value, so optional, let's say with value, is called, and then you say, in this case, this is optional with value, a dot map. If you call this with a function, let's say f, which is going to take a value and transform it, what you get out of this is an optional with a value. So that's a response you get. The type transformation could happen. Maybe the value of type x, maybe the f is going to give you an object of y, and you may get a value of y out of this. But on the other hand, if you have an optional empty and you perform a map of x, this will give you an optional empty back to you, except this is optional empty of type x. On the other hand, this is optional of type of empty y. So you do type transformation, but you continue with an empty. So notice what map did. So here's the way to summarize what we just saw here. Map transforms optional with value, moves, does not touch empty. That's what it really is, right? When I said does not touch, it did a type transformation, but it didn't really do anything with it useful. That's the way map works on optional, on the empty. But on the other hand, if you take or else is kind of the opposite of this. What does or else do? Or else says, if the value exists, do not touch. So just pass it. So if a value exists, what does or else do? It quietly gives you the value. It doesn't do anything with it, doesn't mess with it. If the optional is empty, on the other hand, what does or else do? Inject a value. So in other words, the or else will inject a value if the value doesn't exist. If the value exists, simply moves it forward. If you notice it, to a certain extent, these are kind of like the opposites. Map will transform the value, but quietly ignore the empty. Or else will quietly move the value forward, doing nothing with it, but inject a new value if it's empty. But on the other hand, what if I really want to do the following? I want to do the following, where I say, if the value exists, move it forward. If the value is empty, if the optional is empty, what do I want to do? Inject a new optional. So in other words, here's a way to think about it. In the case of the map is, so to say, injecting a new optional when the value exists and doesn't do anything if it's empty. In the case of this, you want kind of the opposite. If the value exists, just move it forward. If the value doesn't exist, inject a new optional into my hierarchy. Well, how would I actually do that? So that is exactly the purpose of or instead of or else. So if I say or over here, and if I say or else for, I'll get a compilation error because or else for is a number, whereas I'm putting into an optional, I cannot do that. But in this case, I'll say or, and I will put a supplier and return optional of, let's say, 77. So what's going to happen now? If the value exists, you simply get that value out of this. Let's output the first right now. So you will notice that when I output the first, it is the value 6. It's inside the optional. If the value does not exist, then I get an optional of 77. So R is to inject an optional, and then you can continue programming with the optional moving forward, except that or else will kind of give you a primitive or whatever the type is, whereas in this case, it lets you continue even forward, which is really a nice thing to do. So we talked about if present or else, we talked about or, but there's one other beautiful thing you can do with optional moving forward. And that is, if you take a function, we'll call it as process. So I have a public function right here called, let's call it as process, which is going to take a stream of integer. And in this case, I'm going to case stream right here. And all I'm going to do is take the stream for each and call system.out and print it. So this is really nice. And how can I use it? Well, already we can use it as, we can say process and then call numbers.stream, and I can just pass it through and have it printed. That was really nice, wasn't it? However, what I really want to do is take this collection. So I say numbers.stream.filter, maybe given an element greater than 5, and then dot find first. Now that I have a value on my hand, I want to take this value and pass it to process so that I can iterate over the value. Now, you may look at this and say, does this make sense? Well, I think it does. And the reason it makes sense is, this is saying I'm an iterator. How many values can an iterator process? Oh gosh, an iterator may process 0 values, 1 value, or any number of values. What about an optional? An optional is a special case of it. An optional may have 0 values or may have 1 value. So why shouldn't I iterate over 0 or 1 value? I should be able to do it. But it doesn't matter what you and I think. The compiler says you cannot do this because you cannot pass an optional to where a stream is expected. So what do we do? Well, you could do something silly like this. You could first of all figure out if the value exists. If the value exists, you could then create a stream of that 1 value. If the value doesn't exist, you could create a stream of no value, and then you can call process. That's going to be looking really ugly. Why not just simply do .stream and be done with it? And that's exactly the whole idea. So you can take a stream, take an optional, and convert it as a stream, and then it becomes a iteration over one value if the value exists. What if the value does not exist? I run the code and the iteration did work and it didn't print anything because the value doesn't exist. So you can see in this case, I'm going to output done, and when the value is greater than 5, you can see it printed the value 6 and done. If I put a 50, you can simply see done being printed because there's nothing to iterate over. So you can take an optional and convert to a stream very nicely, and that's basically yet another thing we got. So that's where I'm going to stop about improvements and changes that are in the language. And I would say I am really happy for most of these changes. I think they are really good. They have improved quite a few things we can do. I'm sure there's more improvements to come in the future, but I think they have done a fairly decent job in my opinion. So if I were to give the grade, I would say A+ grade, really nice changes to the language. I'm pretty happy for what they provided so far in this case. So that's our improvements and changes. Now, let's talk about some things that are, I would like to call as additions. So what are some of the additions to the language? Well, when it comes to additions, one of the things is we always want to get more fluency. That's one thing. The other thing is we often have programmers who constantly complain, not complain, but constantly compare, and complain too maybe, if it was me, and who constantly compare to, you could do this in this other language. And when you sit down and code in Java, it doesn't really help to keep saying this works really in this other language, right? And I always have this feeling, when you're coding in a language, talking about this other language that you used to program in is like talking to your current girlfriend or boyfriend about your ex. That's not a good thing to do in general. It only makes everybody frustrated, including you and that other person. So in general, we shouldn't really salivate like that and say, you know what, I'll just live with what I have right now, and the past is past, the future is future, and the current is current. But having said that, though, it still is kind of nice to have. This is one thing that gets really programmers excited, right? You show them a little feature, and they're like, oh, that's so nice to have. And I wished my language had it. So we always do this. So you would always say, when will Java have all these other wonderful features from all these other languages? I'll tell you, first of all, the goal of Java is never to do what every other language does. Actually, I do have to tell you, they took Java and they added every feature from every beautiful language that's out there. When they finished it, they renamed it as Kotlin. So it's already there, right? So if you want everything from every language, go use Kotlin and be happy with it. But Java says, I'm going to selectively bring some features. I'm not going to be in a hurry to bring those. And there are some really good features in other languages, but maybe I don't want those features right now because it may make really good sense in those languages. Maybe it doesn't make sense in Java to have it. So they've been really, I'm not going to use the word reluctant, they've been selective in bringing features. But one thing I'm really happy they did bring is a nicety about creating a collection. So if I have a collection of 1 to 10 right now, and I'm going to output numbers right here, you will notice that it says 1 to 10. That was a collection we created. But what kind of collection did we create? We had to really create values in place. I don't want to use .add. That's kind of boring to do. So I don't want to be verbose and boring. So what do? Well, I can throw these numbers using asList. We've had this for a long time in Java. But unfortunately, though, is this immutable? Oh, is it still verbose? Oh, what kind of object is it creating? So if I ask for get class over here, you will notice it's actually an array list class that it created. It doesn't matter how many elements you have. Notice that if I had 3 elements versus 10 elements versus 2 elements, it doesn't really matter. I got an array list. Well, thankfully, you don't have to do this moving forward in Java 9. You can say list.off 1, 2, 3, 4, 5, 6, let's say. And in this case, I have numbers created as list.off. Notice the type in this case is list_n. Now, list_n, that's a specialized type, but this is also immutable. So if you say numbers.add, and I want to add a 7 to it, now, when you write this, the question is, this will not work. But the words, this will not work, is a very loaded word. What does it mean? Well, will it give me a compilation error? Well, the answer is no, of course not, because getting a runtime error is much more fun than getting a compilation error. Well, it cannot give you a compilation error in this case because you are dealing with the list, which is a traditional list. The compiler really doesn't have the information to tell you that you are wrong, so it'll wait until you run the program to tell you. But in this case, when I run it, it says unsupported operation exception, and then it tells you that you cannot do this and gives you an error at this point. So that is immutability. But even better, when you look at the class, notice it says list n, but I'm going to then go ahead and remove these few values down to 3. That's still list n. Bring it down to 2 this time. It's a list 2, if you notice, not list n. Bring it down to 1 value. As you would imagine, it's a list 1. And bring it down to 0 values, that becomes a list 0. So there's no list -1. Okay, so the point really is that it really is a very specialized collection that it creates, and as a result, it can be better in performance as well. So these are very customized implementations. And of course, the question is, how many can you implement? Well, you can try to push the limits, 1, 2, 3, and you can go all the way up to maybe a value of 10. And I was able to really put these values and run the code. You can see that it's a list of n it provided. What if I were to take this and add more values to this even further, and then even further, and then even further? At some point, you should say, dude, you're doing this wrong. So the limit should be our sanity rather than the compiler. So even though people talk about limits, you can try to push it, but you obviously won't go to a very large value, so that shouldn't be a concern. In general, I say asking those questions is a sign of bad design. You don't want to say, how many can I have? So that's basically the idea, is you can create a list like this. Well, this is nice. We had a list of. In a similar way, you can also create a set of as well. So for example, you can go back here and say set.off, and you can create, let's say in this case, let's say John, and let's say this is going to be Sarah, and let's go ahead and say we have another object, let's say Tom over here. So this is a set, obviously, and we know that set is unordered, and essentially when you notice the output, it's not in the same sequence, it's an unordered collection. You can do a set off. In a similar way, you can ask for the get class on this, and that's optimization as well. So if I don't have a Tom right here and run this code, you can see that it's a set too. Likewise, along the same lines, you can also create nicely, and this is something I really like what they have done, map.off. I can say a comma 1, b comma 2, and then maybe c comma 3. And in this case, of course, as you can see, we can create a map with key value pairs given together, which is really nice. But of course, what if I give a key but I don't give a value for the very last one? This is even more beautiful. You get a compilation error. Okay, it really got mad, as you can see. So you can get a compilation error at the point and tells you you need to give a value. And Java will never mildly tell you, right? It throws a big error. It's like, I'm sorry, I won't do this again. So that's the best way to learn. So you can actually put that value and you get an error and you can deal with it. So the key and value both are required. And as long as you give it, that's great. I also noticed that one of the other things I like is a nice little type inferences kicking in right here, which is also a nice thing to do. What if I said 3.0 right here in this call? Well, then the type is going to be elevated to a type that fits into it. So you got to be a little bit careful, but hopefully what you assign on the right side will get inferred. What you assign on the left side will help you to infer the type on this side and deal with it. So type inference works in more places in Java now compared to Java 7. So we've been really going in this direction very nicely. So that is basically what you do with this nice little off method. So the next thing, of course, is about completable futures. Well, in the case of completable futures, one of the nice things completable futures has is two different little features. When you create a completable future, in the past, you could create a completable future to do some work. And if you were in my previous talk, I request you to just have a little patience with me so I can cover this for people who may not have had a chance to look at it. So I can create over here, let's say, a concurrent. In this case, I want to bring in a completable future. So I'll say completable future, and in this, let's say integer, we'll call it as some kind of a future here. Let's actually say dot, in this case, supply async. And with this, let's go ahead and write a function. We'll call it as sample, or let's call this as a factory or a method that's going to generate the data. Well, in this, of course, I can then call this and say, then accept, and we can specify what to do when the data comes in. Maybe I just want to print out the value, so out println. You can do that println like that, or you can say, then run, in which case you will just do some action without the data that you don't care to receive. That can be very useful with the run. So in this case, of course, this is going to wait for the data to arrive, and then it's going to display the data for you. What about the factory method, though? Well, in the case of scary things, okay, factory method right now is the factory right now. This is going to return an integer value eventually, but what am I going to output right here? Well, in this example, I'm going to take some time. So I'm going to say sleep.sleep. Let's say I want to sleep for about 5 seconds, and then I'll return, let's say, a value of 42 from here. So that's going to return that value, and eventually we're going to print that value out and be happy with it. So when I run this code, what is going to be the output like? Well, maybe what I'll do here is just give a sleep to wait for it so that it can be displayed, and we can take a look at the value as an output. Well, that's my little code to work with this completable future. But it turns out, what if this value, this particular call, is never going to complete, or is not going to complete in a very, very, very long time? Well, if it's not going to complete in a very long time, this would end up being a waste waiting for the events to happen. Maybe you want to know that things are never going to happen. So there are two things you can actually do about this. One is you can save away this one into a completable future of integer right here. So I'm going to put it into a completable future of integer. And then let's go ahead and call this as, let's say, future is equal to. And then we'll come here and say future dot. But while I'm waiting for that one, I can say future over here. So this is a future, future, there we go. So given this future, what I can do is I can say future dot, and in this case, we can say complete on timeout. Well, this gives a way for you to declare the win and say, I'm going to send a -1 after maybe only about 2 seconds. And this is time unit dot seconds. So you can ask it to bail out with that value only after about 2-second delay. If the process finished really fast, you will get the result. If the process did not finish really fast, you will get the -1 and you can move on. So that's basically what this is going to do. But of course, if a value was successful or the completable failed already, you'll get the failure and not your timeout at that point. So right there is -1. This is useful to feed some premature value to close and move on. On the other hand, if you really want this to fail rather than continue this way, what you can do is you can go back to the completable future. You can do this while you build it or afterwards. And in this case, what you will do is simply say dot or you can say timeout. So you can ask it to timeout with a time. So you can say 2 comma time unit dot seconds. So in this case, you can ask it to time out at a certain time. Now, clearly in this case, it'll generate an exception. You would have to then handle the exception down below using exceptionally and things like that. But this allows you to time out also as an error rather than giving a dummy data to deal with. So that is one thing they provide with the completable future. The other thing that's available, which is also pretty neat with this, is the ability to copy completable futures. And what copy allows you to do is you can take a particular completable future and you make a copy of it, and then you can execute them at the same time. So this can allow you to take certain algorithms and create a branch in the algorithm and execute different parts and see how they behave. And of course, you can deal with them, the parts completing separately versus the originals completing, and you can play with it. Then the next thing that is pretty interesting to have in here is a stack walker. Yes, stack walker. So what does a stack walker do? Well, imagine you are dealing with exceptions. Remember how we always complained that exception stack is really, really huge? Well, there's a good news. It's really huge, but you can now process it using the Streams API. So it doesn't feel that bad anymore, right? So if you want to really go through the call stack and process it, you can do filters and maps and reduce and stuff like that. You can take a call stack and you can apply a stream operation on it, and then you can walk through it very nicely. So take a look at Stack Walker. If you are somebody who has to deal with stack trays day in and day out, there is some kind of relief for you, and you can use that. One of the features I really like as an addition is JShell. So what is JShell? Well, JShell is a pretty amazing tool in my opinion. And what I like about JShell is it's a REPL that you can use. I'm a huge fan of REPLs. Almost any language that you care to use today has a REPL. For example, Node is a REPL for JavaScript. You can say 2 plus 3 right here, or console, hi, and you can see that work right there. That's a REPL for JavaScript. Similarly, you have a Scala REPL, and of course, in Scala REPL, you can say println, let's say, hello, and that is Scala working right there. So that's Scala's REPL. This is Haskell's REPL if you want to. You can say add AB is equal to A plus B, and you can call add 1 and 2. You can get the result of 3. Almost any language has a REPL. Well, I really like REPL a lot. And the reason I like REPL is I consider REPLs to be, this is of course stands for read, evaluate, print, loop. It reads what you type, evaluates it, prints it, and loops over. Why should we care about it? One of the reasons I really like about REPL is it facilitates what I like to call as a fine-grained incremental development. Now, I'm a big fan of automated testing. I'm a big fan of writing unit tests. I write test, write code, write test, write code, write test, write code. But even then, I think that cycle is too slow for me. I have a test that's failing. I've got to make it pass. But when I look at the code, I'm like, wonder what kind of functions I can put together here. Well, I don't want to really think about it, write it, and watch the test to fail. Even though it's relatively fast, that's still in another order of magnitude, it's really slow. But instead, what I normally do when I program in these languages is I flip over to the REPL, try out a little experiment, a little code. Can you imagine where this can be really powerful? Imagine you're working with the Spring application. Imagine you're working with the web application, and you can inject yourselves into that environment using a REPL, and now you are interacting with your server-side data, and you can start really querying for things. This is like you are given a power to minimize yourselves at the micro level, and then inject yourselves, and you're able to see the world around you. That's awesome power, right? It's like taking debugging to the next whole level, in my opinion. So you can sit there and play with the environment. And I do this quite often when I program in languages that have REPL, and I've really done this for several years. I was working with a developer not too long ago, and he said, I wonder how would this be? And I said, why don't you try this in the REPL? And he said, yeah, I should really start using the REPL more often, because this is a habit we develop over time. So it's a micro incremental development that's really nice. It's nice to prototype, little examples you can play with it. It's a great experimentation tool, and it's also a really good learning tool. When I teach my students about different languages, it gets tiring if you have to set up projects. By the time you set a project, you forgot what you went there for. Well, you open up a REPL, type in a few examples, and I would just save that as a script and send them and say, go try it on your machine. They can open up the REPL and play with it also. That becomes really, really easy. So the first thing I want to show you is, how do you start the REPL? To start the REPL, you will type JShell, and in this case, that brings up the REPL. One of the things I learned very quickly is, when I get in somewhere, I learn how to get out. So Control D brings you out. That's one way to really exit. There is also another way to exit. You bring into the shell. If you want to exit, you can do Control D and get out very quickly. But maybe it's a very slow day at the office. Maybe there is nobody and you feel really lonely. Then you can type exit. It'll even say goodbye to you, which is really nice. So you can use either of those mode depending on your mood, right? If I want to really get my work done and going, I would hit Control D. But if I want to have a conversation with JShell, I'll do it /exit. But this also tells you one other thing. when I bring up J shell, sometimes you have this, right? You have somebody asking you a question, they're talking on the phone, they're asking you a question, they're talking on the phone. At some point, you're confused. You're like, are you talking to me or on the phone? Well, that's exactly the problem here. When you're typing something, are you typing that to Java, the JVM, or are you typing it to J shell? Well, if I type something here, 2 plus 3, that is to the JVM. If I type slash over here and help, that is to the J shell. So slash is commands for J shell. Without slash, you're sending commands to the JVM. Here's another beautiful thing you can do here. If you ever had to teach Java to somebody, remember that fateful day? They came to you and say, is Java easy? You said, oh, Java is simple. Don't worry about it. Can you teach me something simple? How about teach you hello world? And they take a piece of paper and say, yes, I want to learn hello world. You said, let me show you hello world. And what did you do first? You went to the editor for them. And the first thing you did was you said public. And their hands goes up and says, what's public? You tell them you don't need to know that right now. They take notes. Public, no need to know that right now. Then you said class. They say, excuse me, what's a class? Oh, you don't need to know that right now. Then they say class, no need to know that right now. Then you said hello world. And there's a glimmer of hope in their eyes. They're like, finally. And then you put a curly bracket and they're like, okay, what does that mean? Then you said public. They immediately, a very smart student, they look up their notes, public, I know that. No need to know that right now. Then you said static. And they completely lost it. And they ask you, is static also something that I don't need to know right now? And that is a lot of baggage on our shoulders, isn't it? Well, we don't have to do this. We can simply say system.out.println, and I'm going to say hello, and isn't that beautiful? And for the first time ever, Java with no semicolons. This is awesome. This is amazing, isn't it? So you can just type that little snippet and you can let it run. You kind of even wonder, right? I mean, the other day I was writing code in Java and the compiler said, you are missing a semicolon. And I had this argument. I said, I'm not missing it really, you see. And the point really is, I don't want to be doing all the stupid things I don't have to do. Thread.sleep 5,000. I'm sure you've had this nightmare, right? You are trying to call thread.sleep, and the compiler says, you will handle the exception. And you spend a sleepless night thinking, what do I do with this exception now? Well, you don't have to. Just call the sleep 5 seconds later, you get the response back. As you can see, that works really well also. So this shows you how you can remove some of the ceremony. Of course, if you're going to write a method, you would have to bring in the semicolons and the necessary try blocks, because the methods that you write have to be complete in the syntax. And also, we can take these methods and bring it over to code, and that can be very useful. So we went in and tried a little hello over there. These are called the snippets of code, and we can try different snippets. For example, I can say 4 plus 3 here to get the value of 7. I can deal with that really nicely. It even saves it away into a variable, which is $4. So $4 plus 12 right now is 19. As you can see, that's 12 plus 7, which is 19. So you get that value really nicely also. So you can use those kinds of expressions. And then we talked about exiting also. But here comes the charm. You can use the up arrow and the down arrow back and forth, and you can re-evaluate the things you already wrote, so you can use the up and down arrows. And similar, if you want to go to the beginning of this, you can do Control A. You want to go to the end of it, you can do Control E. If you want to go to the other words, you can navigate. In other words, I simply blindly started typing things I'm already familiar with on the command line, and almost everything worked here as well. So that's one of the nice things, is all those things really work nicely. So you can do that, and then of course here's a Control U to get rid of it. And I'm a person who like to keep things clear in front of me. I have this habit of typing Control L all the time to clear my screen, and that works also really nicely. Control L to clear your window. That can be really powerful. So you can use the up arrow, down arrow, Control A, Control E, and then comes along something really, really exciting. Let's say I create a string, greet is equal to, let's say, hello, and of course I want to type greet right here. But remember how some developers tell you they love IDEs, because in the IDE you put a dot, and before you could blink your eyes, it would, oh, here you could do wow, that's really interesting, isn't it? So you can get a list of methods as well. Well, you can just do that very nicely. Or you can say concat, type minimally, and hit the tab. And then something even more beautiful. You type the tab, and then you type it one more time, it even gives you the Java doc. Can you believe it? I literally cried that day when I saw this. This is like, oh, this is amazing. So I mean, when I'm on the flight, I don't have to go look for stuff. I can put a dot and see that right here. I don't need to use a IDE if I don't want to. I can just look at it right here. So that's really nice as well. And you can take a look at the beautiful capability. Just double tab rather, gives you the documentation for it too, which is really nice. What if I want to repeat a command I just typed? So for example, if I want to type over here, let's say hello, well, I did type hello, but I want to repeat it. Remember, slash is a command to the J shell. One, I'm asking it to type the command one, that was whatever the command one was, and apparently that was 2 plus 3. Or I can type this over here and say slash bang, and that is saying execute the previous command. So this is much like your Unix environment where you can put a bang bang and run the previous command. In this case, a slash bang executes a previous command for you, and you can use that. So that's a nice way. -n is to go execute that many commands further out. So -3 is the third command moving backward from here. Similarly, you can look for your current imports. So you can say imports and see what imports are already loaded. If you want to really use your own environment, obviously you have your own classes, you have your own stuff, and you want to be able to look at those. When you start J shell, use --class-path, not class path, class-path. And when you say class-path, you can load those classes in your class path for J shell to be using. Then you can start querying your own classes, import them and use them, or you can set up a script which will import them ahead of time. You don't have to manually type it. Well, but if you don't do any changes, these are the default things available, which is good and bad in my opinion. What is good? They said you will give you util for free, which makes sense. Have you ever written code without using util? Most of the time we use it. Nice, welcome. IO, math, okay. Net, yeah, maybe. They think concurrent is needed. This is the one that really surprises me. They think that we need to have regex all the time. But anyway, you can have that and you can deal with it. That's available for free. You don't have to really do an import. That's nicely available, and you can use it if that's what you want to do. So that's your import. You can do a list and save, which is really nice to find a listing of all the source you wrote. So you can say list over here, and that's all the code we wrote. Similarly, you can do a save and put it into a file name. And so after you type all of this and play with it, you can dump it to a file. Similarly, if you already have things in your file, you can just open it and execute it, right? So you can load it as well, which is really nice. I want to know what variables I have in my code so far. V will tell you what your variables are. I don't know if you remember, but I defined greet, and that's there, and the other internal variables it created. You can also do var if you wanted to. It's the same thing. Similarly, M for all the methods you have. Similarly, T for all the types or classes that you have. Had you written a class, my class over here, and now you say T, you can see my class is appearing right there. So that tells you what types you have, interfaces, classes, and stuff like that. But one of the really cool things about this is not only can you add these things, but you can also do a couple of other really exciting things. So for example, I have greet over here, and I want to change it to hi, for example. I can change it this way. But you can also do something a little different. You can do a /edit, and then you can put greet right here, and it opens up this beautiful little, what do you call it, a display, and you can just go in here and change this to some other value right here. And then when you're done with it, you can click on accept, you can quit on it, and then you can ask for what greet is. Isn't that cute? That has the value right there. Why is this something you should do? Well, if I want to do not an exit, but edit, well, I can just do an edit without anything, as you can see. Then it actually gives you a lot more broader scope of things as well, which is really powerful. So if you want to quickly make some changes or put a little bit more multi-line functions, it's a little hard to do this on the command line. You can open up this, type multiple lines on it, then click a save, and it accepts it. So this can be very, very powerful way to really make those changes. So /edit gives you that little thing to play with as well. So you're not confined to just the command line available to you. One of the other real beautiful things is, I already talked about semicolons and try and throw. Well, the drop is a really phenomenal function. So V tells you all these things. I'm going to drop $8 over here, and I drop the variable. Now, if you look at the variables, you don't have 8 over here. You can drop all kinds of stuff. So I have a class called my class. Drop my class. And in this case, I drop the class, no longer present. So you can drop them from your environment as well. Well, what if I said void foo? And in this case, I'm going to say output a foo called. And then, of course, in this, I'm going to call a function called bar. Semicolons are required, and I'm going to close it. Well, you know very well we don't have a bar. So it gives you a little warning. It says, created method foo, however, it cannot be invoked until bar is declared. You know how programmers are. When you say you cannot call it, they want to call it. So what is going to happen if you call it? It says, I told you don't call it, right? So attempted to call foo, which cannot be invoked until method bar is declared. So that's what it tells you. Now I'm going to create a bar method. In this case, of course, I'm going to output bar, and then, of course, I'm going to close it. Now bar is available. Now I can call foo, and that called the bar. But then you come along and say, aha, I'm going to drop bar. And maybe the J shell is sitting and shaking its head right now. It's like, what are you doing? But then I call foo. It says, here we go again. You're not supposed to do this. So you can drop stuff. You can put them back. There's a nice little experimentation environment. It's a playground, isn't it? This is when Java is actually kind to you. And just have a good time playing with it. And you say, is it okay if I don't use semicolon? It says, we are just having a good time. Keep going. And then you can play with it. So that's basically what this is doing. It gives you that ability to just be playful and write some code. There are a few limitations, of course, you have to run into. From time to time, you will kind of run a few edges, but don't be too unhappy with it. For example, J shell doesn't really care about final. So if you try to do final, let's say int a equal to 4, J shell says, I thought we were having a friendly conversation here. Now you're trying to use legal terms on me. Don't do that. So it doesn't want you to do anything really strict and really formal. Just kind of play with it, be happy. So there are a few little restrictions that you have in this case. And we saw defining variables. You can also infer the variable using a really good shortcut key, which is called a fixed shortcut key. In this case, it's kind of like what you do in editors like IntelliJ. You define an expression, you press that key, it'll fill in the type and give an opportunity for you to define a variable name. You can redefine variables as well really nicely. And then, of course, you can define it as a different type also. Because remember, this is just an experimentation area. You can define methods. We saw that. You can redefine methods. You can define classes. You can define interfaces, find the methods, find the types. You saw me do all of that. We did forward reference also. Remember, I called foo without defining bar. So I was able to call bar in it. You can also look for history. What's the difference between history and list? List is a listing of your source code. History is every interaction you had with the J shell environment. So if I say history over here, notice that it's a drop and the bar and everything sitting there. List will contain only the code, of course. So you can look at both of those and look at whatever you want to look at in terms of looking into it. Like I mentioned earlier, I really have to tell you that I love J shell. It is one of my favorite tools. I like to really get instant feedback and play with things. And I'm just experimental in nature. That's just the way I'm wired. So this is a tool that I really definitely like. I've used REPLs in a lot of other languages. And as a result, I like REPL in Java also. So I'm really happy that they have that in Java 9. Well, that takes us to the end of the second part in here. We talked about the improvements and changes. We talked about the additions. Now we want to talk about the last category here, which is the advances, as I would like to call it. And in that area, I'm going to pretty much talk about one big elephant in the room, which is modularization. Now, modularization is a very key feature in Java 9, maybe the most disruptive feature. And here's my take on modularization. Modularization is like parenting. Children never appreciate you when you are parenting them, and they eventually come back after years and say, say, you're not that bad, thank you. And that's the way we're going to feel about it. That's my optimistic mind telling me we're going to kick and scream and complain about modularization now, but in the long run, when the dust settles, I think we'll be thankful that we have this. So we're going to talk about modularization, but I think we should do that in the next module, if you don't mind. So why don't we take a short 10-minute break? When we come back, we'll continue with modularization after that. Thank you. All right. Thanks for coming back. Let's get started with the second part here. We're going to talk about modularization. Let's talk a little bit about the problem we are trying to solve and how modularization can help us with that. But before we talk about it, let's talk about something we've seen in the past. Well, we've had solutions like OSGI available in the past. I've used OSGI. I've really liked it. OSGI is extremely ambitious. It does a lot of things. Java modularization does not do enough of what OSGI does. So it's a very small part that modularization actually solves. In that sense, Java 9's modularization is not ambitious. It is rather very practical and pragmatic. They want to take one problem and find a fairly good solution to that problem or a small set of problems, then trying to make something work for a lot of different combinations and possibilities. So the objectives and the goals were extremely different. But what are some of the problems we deal with? The very first problem is the jar sizes. Does anyone remember the size of RT.jar? There you go, still counting, right? So that's 68 megs in size. That's a big, big jar. Raise your hand if you use Swing. Okay, very few people, right? But the rest of us, don't worry about it. You have it with you. And if you ever need it, never worry about it, right? It's there, you can reach in. That's like saying, you got to carry these 3 bags on your trip. What are these 3 bags? Don't ask the question, just take it with you, right? That's how it feels. You got everything bundled up together, whether you want it or not, and you just keep lugging it around. And that's basically what we have been doing is this monolithic big blob we've been carrying with us. There is a lack of clarity of dependency. What does your code depend on? And there's a little gulp, and it's like, well, let me see, let me find out. The other day, somebody told me, hey, don't you think you can find this using Maven? And I reminded him, nobody uses Maven, Maven uses you. So it's something you have to keep in mind, right? So it drags you in, beats you down, and says, sit down now, and then you start using it. Well, but also keep in mind, whether it's Maven or Gradle or any tool that you use, Gradle itself falls back on a lot of Maven repositories to get the details. But the point really is, it doesn't matter what tools that you would use, all of those are compile time dependencies. What about runtime dependency? Well, the short answer is there is not a whole lot to deal with that information. We are pretty much lacking in that area. The other problem is public is too open. You write something and say, hey, don't use this, please. And then people start using it. It's like, I told you not to use it. Well, you said, please, so I kind of took the liberty. Well, but public is too open. What if we want to create something but very much clearly dictate permissions as to use it or not? That would be really nice. And the last thing is, how does the class path behave? In the class path, you have 2 options. You have a fail late or fail early. Which one do you think is better? Fail late or fail early? Fail early is better, right? Fail fast is better. Well, imagine you leave the room without the keys. It would be nice if you can know that you left without the key by the time you leave the room, then walk 3 kilometers and then find out you forgot the key back in the office. That would be really painful. Well, in the same way, let's say you deploy your application. It runs for 5 days, and on that fateful afternoon, the user hits a feature, and that's when the class path bonks on you. And I always feel like Java, when you compile Java and start running it, Java looks at your class path path and says, oh, this is going to be fun. And it's just waiting for you to fail eventually, right? That's not really fun at all, because you would rather know that this is not going to work when you start than to be known later on that this is not going to work. So fail fast is very important. We're going to see this all in a little bit and see how this can work. So this brings us to the so-called a modularization technique. But one of the really beautiful things about this is packages now go into modules. But what's really cool about this is that the JDK itself has been modularized. How many modules do you have in the JDK? Well, let's find out. So I'm going to go back over here to the command prompt right here. And in the command prompt, I'm going to ask the question. Let's kind of bring this out. So in the command prompt, I'm going to ask the question, Java, and I'm going to say list modules. List modules tells me all the modules that's available for you in Java. Here we go, boom, and that's all the modules. How many are there? Well, let's take a look at it. That's how many there are. That one little RT jar, well, one big RT jar we saw has been broken down into all of these things. Let's see what are some of the things we have. We have java.activation. We have java.base. Java.base is one of the most important things. This is where your Java lang and stuff like that are contained. Then there is java.compiler. And there's java.core. It never goes away. Okay, so you can see that all these things are sitting there, and you can see all these modules, and how many are there? Well, you can see, if you notice, WC minus L, oh my gosh, 94 modules in this case. So keep that in mind, 94 modules sitting in there. That's how our JDK has been broken down into all those modules. Well, some rules. The first rule is no cycles at compile time. Every single module depends on one module, which is java.base, except java.base itself doesn't depend on java.base. So every other module depends on Java base. And as a result, you have this hierarchy built up in front of you, and you have clear dependency being specified, and you have all these things with no cycles at compile time. So what's a module? A module is a collection of code, packages, source code, compiled into bytecode, obviously, data, and then, of course, you have resources and stuff like that. A module has a name. A name is simply a reverse DNS name. So make it as unique as you can. So that's a name. And then it has two other things. It has usually a requires, and you have exports. Requires tells you what you need. Exports tells you what you are giving. Well, a couple of things to keep in mind about exports and requires and modules. So the very first thing to remember is when it comes to requires, the requires only modules. You always require modules. You never require packages. And then when it comes to exports, exports only packages. So you will require modules and you will export packages. It may appear a little strange in the beginning, but once you apply logic to it, it becomes really easy. Your module contains packages. So you will export packages. You will say, I have 7 packages. I want to give you 3. The other 4 are my business. I'm not going to give it to you. So that's why you export packages. But why not require packages? The reason is that's based on the release reuse equivalency principle. The release reuse equivalency principle says that everything you use is what you should be releasing as one bundle, not part of it that would become reusable. So you would not want to really request for parts of a module, you get the entire module. So you give modules, you give packages, but you get modules on the other side. So that's just where you are going to build this, and you're going to have these kinds of facilities available. Now, given this, of course, we are going to build around these modules. Let's take a look at example of how to build it. Now, before we do that, a couple of small important things. The first thing to keep in mind here is that when it comes to dealing with, let's say, Java 8, Java 8 was all about how you modify your code, isn't it? Well, that's the way Java 8 was built. It's all about how you change your code, how do you design your code. That's what Java 8 was all about. Well, that whole game changes when it comes to Java 9. Java 9 has modularization has very minimum code change. It's almost all about how you actually work with code. So to make my life a little easier, I've got a few scripts here from the command line, no bells and whistles, no other tools, purely Java, Java-C, and Java we're going to use to build this stuff. So let's get started with a little example. So the first thing I want to do is to build a module. So to build a module, let's first take a look at the code we're going to create. So for this, I have a directory called _creating modules. I'm going to open up all the Java files in here, and you will notice that I have a class called Fibonacci. Well, where is this located? It's located in a package called com.agiledeveloper.util. So that's the name of the package I created, com.agiledeveloper.util. And then, of course, it imports this my helper from this other package. And Fibonacci says, excuse me, you will notice that it says, well, it's purely Java code, nothing really exciting. Close that out. Then comes along helper interface. That's also part of util. Great. Then comes along my helper. My helper is part of IMPL, and it kind of gives us a wind. You would not want other people to get access to your IMPL package directly, so we won't export this. Well, great. So I have this my helper sitting right here, and the my helper also has a hidden, if you notice. We'll talk about all these and see what we can do with it later on. So that's basically what we have so far. Now comes along one interesting file called the moduleinfo.java. Now, what is moduleinfo.java? Notice the file name, module-info.java. If that name looks weird to you, it definitely is weird. So there's only one other file that's as weird as this, which is packageinfo.java. Packageinfo.java was introduced a few versions ago in Java, and it contained by far the most useless information, a little package level documentation. Module info is not like that. It actually contains something useful. What do you put within the module info? The first thing you put in module info is module, first of all. Wait a second, stop right there. Module, wait a minute. Well, does that mean module is a keyword? So step back to Java 5 for just a minute. What they really wanted to create was for each and then string name in names. That would have been so beautiful, isn't it? But they couldn't do that. Why? Because the problem was, what if people are using for each already? They actually found out a lot of people are using in as a keyword. So this was kind of like, gosh, what do we do about it? So they figured out, let's put a stupid colon in here. And as a result, that's not a keyword, we can use it. Every time I type this, I go into a corner and cry because this is not as elegant. In fact, I was on the flight yesterday writing some code, and I had inadvertently typed in. That's my deeper inner likings. And I say in, and Java says, I don't know your syntax. Of course you don't know. And I start coding away after that, right? So that's really awkward, but you had to do that. That's because the keywords are significant in languages, and as a result, they couldn't use it. Fast forward to Java 8, what did they want to really do? In Java 8, they wanted to say interface, and you have an interface called util. You want to write a method called foo, but the method foo had to be implemented. So you want to say that you are implementing this method, not abstract, but you're implementing. You could have said implemented, right? Well, you cannot do this because I'm sure somebody has a variable called implemented someplace in the world. So what did they do? They were very clever. They said default. There's a reason why they called it default, because default is already a keyword in the switch statement. So they hijacked it. And I'm so happy they used default rather than colon one more time. So I'm happy for that, right? So this is really good. But the point really is, we are back to square one, aren't we? Every time the language needs a keyword, you're like, gosh, I'm going to compete with the world of developers using the keyword. Now enters module. Now what now? Well, thankfully, module is a very interesting variable. Module is a keyword only within moduleinfo.java. If you're using module anywhere else in the code, whatever that means to you, it doesn't mean this module. And that's one of the nice things. So it's a very contextual keyword rather than a very broad keyword in your language. So in this case, module, and I'm going to give a name for my module. And I called it as com.agile developer. Call it whatever you want to call it with a proper, reverse DNS. Oh, by the way, you cannot put a number. So don't try to put a number into it. It doesn't work with numbers. Just be a little civilized and give a good name and be happy with it. Don't get tricky on it. So this is the module name. That's what you're providing. So right there's the module, and then you said com.agile developer in this case. I'm going to make some mistakes as I work on this. Some of the mistakes are intentional. Some of the mistakes are not intentional. I won't tell you which one is which. So in this case, I'm going to just leave this as a module for now. And notice what I'm missing. I don't have any requires. I don't have any exports. Well, what I could do here is I could have said requires. I could say java.base. This is totally unnecessary because every single module automatically requires java.base, so you never ever have to say this. And remember, have you ever written a program where you did not include, let's say, java.util? Mostly we use it, and yet you have to always say import. Well, thankfully, you don't have to do that for things like java.base, because things like java.lang are so useful. You use that almost all the time. Well, so absolutely, it's going to be available for you all the time. So you never have to require it. So in this case, that's all I created. What is this going to do for us? Let's go ahead and compile this code. So up to this point, what has been different? Only those 2 lines are different, right? Everything else was Java 8 code or Java 7 code or earlier. Just these 2 lines are the only different. Where does this module info.java go? Well, back here, I have a directory called com.agile developer, under which I have com agile developer, under which impl and util. But if you notice, right at this level, under the com agile developer, I have the module info.java. So in short, the module info sits at the same level as the beginning of your package hierarchy. So if your package is called a.b.c, wherever that A directory is there, put the module info in that directory. So that's where it sits. Well, with all that said, let's now take a look at how this is going to work. So I'm going to blow away my output directory. I'm going to create a mlib directory under output. Then what am I going to do? Then I'm going to ask it to perform the following. I'm going to create a directory classes, compile javac -d. Notice no magic. All I'm doing is compiling every single Java file in my directory, including module info.java. So all that is just to run javac. But when you run javac, Java now knows that special named file called module.info, and I put a jar, compile it into util.jar. Again, jarring doesn't appear really that difficult at all, different at all. Occasionally, you can give a module number to a jar file. Let me just get that out of the way by talking about it right now. Module number has no meaning whatsoever. So module information will contain the module version number. The version number is a glorified timestamp. Nobody cares about it. Nobody uses it. So if you want to put a module number, be happy and put it. Maybe in the distant future, we may have use for module numbers. Right now, we don't. So that's basically what we did. We just compiled it. Well, once we compile it, let's actually compile it. Make sure it compiles and see if there are any errors. Hey, good news, there's no errors. Let's look at the output directory mlib. There's our util.jar sitting. A module is just a jar file, but it's not just a jar file, it's a module file. Well, how do I look at it? How do I know what's in here? Well, to do this, let's take a look at the jar, and I will say, in this case, -d. -d will give me the description of this jar, so I can find out what's in this jar file. So -d is a useful command. So I'm going to run the -d on this, and it tells me my jar is containing a module called com.agile developer. It not only tells me that the module contains that, but it also contains a mandated Java base. It also contains an impl, and then it also contains a util. So it tells me what packages I am holding on in my module that it tells also. Well, but I didn't export anything. Keep that in mind for a few minutes. So we created this. We requires and exports. We quite didn't do that, but we'll come back to that a little later. Now, I want to use this on the other side. How would I go about using this? In order to use this, let's go ahead and go to this second project and play with it. This is going to be using this code. So if you notice right here, I have something called first user. The first user is part of the com.agiledeveloper.user. And in this case, what is the benefit we got out of this? Well, let's talk about this real quickly. When it comes to class path, if I have a package in my class, in my jar, and I have a package, internal class, somebody could come along and say, I got a great idea. They could create a jar with my packages in it. And then, of course, they get a backdoor to talk to my classes. And what does Java do when it sees multiple jars which have the same packages in it? Java looks at them and says, well, these are very interesting people. And that's all it says, right? It doesn't really complain about it. Well, that changes now. When you have modules, a module cannot exist in two jar files in the same directory. So if you have two jar files in the same directory, and if both are saying the same module name, Java will give you an error. If you have two different module path directories, but you have jars with the same modules with the same name in both, it'll take the first one, ignore the second one. So you will never have a conflict in there and a collision where you can probably bring in inappropriate classes and start interfering with this, that safety is there. Now you have a first user. Main, I bring in Fibonacci with an import. Code looks exactly the way we write code in the previous versions of Java. And then, of course, I call the fib. I printed that. I have a use helper. What am I doing in the use helper? I'm asking for the Fibonacci's helper, which is the helper interface, and I'm printing it out. Let's leave it at that. We'll come back and see what this is going to do. So now this is called com.agiledeveloper.user. But what do I want to do? I want to create a module for this. So I'm going to say module, and then I'll say com.agiledeveloper.first is the name I gave for this module. Again, no requires no exports at this time. Well, maybe I could do an exports, who cares? So exports, and what am I going to export right here? I'm going to export the util package that I have with me, user package I have with me. I'm going to export the .user. Okay, so that's all I did. Let's go ahead and compile this and see what it's going to do. So if I compile this now, I do a Java C, I provide the -p, that is for the module path, not your class path. So moving forward, we use module path and we will not use class path. Well, I'll change that statement a little bit later. During the period of transition, we may use a class path, but in general, we'll use module path. Then I say where the destination is, compile all the files in the _to_ using modules directory, and once you compile, jar them all up using first.jar, and the main class I want to use here is the first user. So I put the main class when I compile the code. And then, of course, I'm going to blow away all the classes. This will not compile, unfortunately. Why wouldn't this compile? Well, the reason it will not compile is, the way this actually works is, think about this as a handshake. I may extend my hand, that doesn't mean a handshake happens. You have to extend your hand as well for a handshake to happen. So both of us have to extend the hand for a handshake to happen. So this has to export, this has to require. If I did not export, or if you did not require, then there is no handshake. Well, in this example, I did not export my package, and the first module did not require my module either, so there's no hands involved at all, so there's no handshake, so it's going to fail. So when I run this, let's see what it tells us. I got an error. Let's look at the error. It says package com agile developer util is declared in the module com agile developer, but module com agile developer first does not read it. I have to admit this to you. the error messaging is beautiful. It actually is something you can finally understand. Usually when you get an error, you call a team of people to ask you to read it for you. And everyone has an opinion. This one kind of spells it out really nicely, right? So very well written messages. I really like what they have done here. So what am I going to do to look at this? Well, the very first thing I'm going to do here is I'm going to go to the Agile Developer module, and I'm going to say exports, and I'm going to export com.agiledeveloper.util. I'm going to export it. Notice I did not export the com.agiledeveloper.impl. IMPL is mine to keep. I'm not going to give it out right now. But I will export the util for other people to use. So as an author of a package, I have exported one package, I have withheld the other package as internal to me, and that's what I'm keeping at this point. Well, that's great so far. Now on the other side, what I'm going to do here is this is not enough, right? So when I go to compile this code, I still get a compilation error. Why? Because you're not reading it still. So what am I going to do? Now I say requires, and what am I going to require in this case? Wrong place, pardon me. I'm going to go to the other module, which is going to be the one we are going to use in the 2. So this is going to be module info, and this is from the users. And what am I going to do with this module info? Well, with this module info, I'm going to say requires. So requires, and this is going to be com.agiledeveloper. That's what I'm going to require. Remember, you always require modules, you export packages. So in this case, the first is requiring com.agiledeveloper, and the com.agiledeveloper is exporting util. And of course, my class wants to use util, so everybody is in harmony. So when I go back and compile this code, in this case, notice that it did not complain anymore. Well, that's great. No complaint anymore. So let's go ahead and get rid of this information so we don't see the output. But I want to run the code now. So what's going to happen when I run it? Here are 2 ways to run it. Java -p, give me the module path, -m, which is for module name, and tell me the module name. Or tell me the module name / and the name of the class you want to run as the main class. So if you don't give me the main class, it uses the main class already compiled into. Otherwise, you can change the main class by. So notice that in this case, you don't say the main class alone. You say the module name / main class to run it. So let's see if that works. So if I go back and run this code, you will notice that it calls the Fibonacci, and it did. Right there is the output. It also was able to get the helper and print it out. Notice it says my helper because the real class is my helper, even though the interface is helper. And then, of course, you can see that it's got a hidden method. I was able to find out it has a hidden method. We'll come back to those and talk about it. I just reran it second time, and you saw that appear both the times when we ran it. So those are the 2 ways to run it. I'll remove the 1 way to run it so it doesn't appear so noisy. So we can look at the output when we run this, and it displays the Fibonacci value, displays the helper object, and also tells us what the my helper contains. Those are the information we saw so far. So what did we do? Up to this point, we looked at readability at this point. We also did exports. Public is not the same anymore. In this case, notice that I have in the code I have so far, I have a class called my helper. Remember, my helper is public. My helper is public, but it is part of the impl package. Remember, I never exported the impl package. I never gave it the impl package. So what's going to happen now? Because I did not give it the impl package, if I go to the first user, I got the helper here, as you can see. But if I say over here, my helper.helper, in fact, I'm not even going to do anything more. Just put an equal to null, as innocent as that is. All I'm doing is I'm mentioning the name of this particular class, right? What's going to happen when I mention the name? It immediately says, you shall not mention such names, right? So it's unmentionable because it is completely hidden. You cannot see it, so you cannot talk to it. That's what you just saw here. So you cannot really talk to it because talk about it because it's supposed to be things you don't see. You are completely hidden from you. We'll talk about that a little bit more. Public plus exports is visible now. Well, notice how we had our Fibonacci class. It's public, but it's part of the package, which is util that was exported, so we are able to access Fibonacci. Public with no export is not visible. And this is true at compile time, and it's true at runtime as well. And that is one of the beautiful things about it. Notice I go here to this code. I'm not accessing my helper now, but what I'm going to do is I'm going to quietly use that using reflection. So notice I went to the helper and I said, hey, helper, do me a favor, please. You are an interface. Could you tell me what your class is? Yeah, I'll tell you. My class is my helper, but you're not supposed to know that. It's a string. You cannot do much with it. Then you say, hey, you, get me your method called hidden. It says, okay, fine, I'll give you a method called hidden. You got the method called hidden. Well, notice when I have the output shown up here, you can see the method hidden being displayed right here. And now you're like, oh, this is awesome. Let me get this done before anybody looks at me. And then you're going to say method.invoke, and Java says, I've been watching you, right? And it says, this is how far I'm going to let you go, not anymore. And slap and back to your desk now, right? So that's basically where you can do that job. So when you run this now, what's going to happen? Well, at this point, boom, error. First user cannot access class my helper in the module because module Agile Developer does not export IMPL to the module first. That couldn't be any more descriptive, right? Really nicely done. And they tell you cannot access it because you cannot touch it. It's not visible to you. You didn't ask for it. They didn't give it to you. Well, okay. So, all right. Let's comment that out for a minute. But before we go any further, I want to show you one more thing which is extremely valuable. And that is, let's go back and run this and make sure it's all working fine. And notice it worked just fine. Great. But let's go back here and only grab the Java command right here. Put it on the command prompt directly, and that is working. Not a problem at all. But I quietly sneak around, and I go to the output directory, and I delete util.jar. So I got rid of util.jar. In the world of class path, what will happen? In the world of class path, you start your program and Java is just sitting there and chuckling. This is going to be fun. Let's just wait and watch. Well, and then it's going to crash and burn later on. This is all about fail fast. Now notice I got rid of the util. Now I go and run the program with the first, an error during initialization of boot layer, find exception, module, Agile Developer not found. It is required by first. This is because the dependency graph is available at the beginning of your program. Every module specifies what its dependency is. So Java is able to quickly build the dependency graph and verify that all the members of this graph are available. If any one of them is not available, it can immediately tell you, sorry, can't take off. This is really broken. We don't want to fail mid-air, right? That's what it's saying, really. So that is already built in, as you can see. I'll just go ahead and rebuild it to regenerate the util class, and things are working again, as you can see. So that's what we saw so far. One small detail I want to quickly talk about is a slight variation. If you go back to your module info, and this module info, where is this? This one here. Here's something you could do. Notice how I said exports com.agiledeveloper.util. Well, maybe you say exports com.agiledeveloper.impl, but I don't want this to be available to the world of programmers. I could say to my cousin, right? My cousin only gets this, not everyone else. If you want it, you got to be my cousin too. Well, the point really is I can specify my module that I'm exporting it to. This feature also has another name. It is also fondly known as bad idea. So, it's usually not a bright thing to do. So don't do this too often. This could be something you do very rarely. If this reminds you of friend in C++. That also tells you why this is a bad idea. Friends generally are not a good idea. I'm talking about programming wise. So keep that separate, keep it clean. Why is this such not a good idea? The reason this is not a good idea is all of a sudden we are now introducing coupling to other module names that can make our things brittle, right? So then as you start expanding it, this can become really messy. So in general, don't do this. If you did this my cousin module will get access to this IMPL's public stuff, but no other module will get it. But in general, don't do that. So let's get rid of that. So that is about export to. That's why I avoided that. It's better to not do that. But let's talk now about implied readability. So to understand implied readability, let's go back to the problem we have at our hand and understand what's going on. Now notice, in the first user, the first user says, I am using Fibonacci. Well, yeah, sure, you can, because the Agile Developer exported it, you are importing it, awesome, not a problem. But when you look at this over here, this guy has a method called handover. What does handover do? Handover says, I'll create a Fibonacci and give it to the caller. Let's understand the consequence of this. Let's say we have Bob over here, and Bob has a module. We'll call it as Bob module. And Bob module is going to export the packages. Well, we here have Sarah module. And what does Sarah module do? Sarah module requires Bob's module. So that's working really well. Now, Bob has a class called B. Sarah has a class called X. Now, what Sarah does is, Sarah has a function or a method in class X that says get B. Well, look what just happened. Sarah says, I am generously taking this object B and giving it to anybody who asks for. Well, now I have, let's say in this case, Jane module. What does Jane module do? Jane's module says, I am going to require, in this case, and I'm going to require Sarah's module. Well, good news, Jane can use X, right? So X is available to Jane because Jane and Sarah are shaking their hands. Now, at this point, independent of anything, right? Nothing to do with X. If I say new B, this is an error, right? Why is this an error? Because Jane did not shake hands with Bob. So you cannot get Bob's class because you don't require it. Well, so you cannot do this. Great. But I am going to then say the following. Instead of this, I'm going to say, well, B, object B equals, let's say new X dot get B. If I do this, now what just happened? Well, I am accessing B over here, but I'm accessing B using the object X, which is allowed, which is legal. But when I get B, it returns an object. If I said object B equals new B, this is fine. This is not a problem at all. Java will not stop you. Java simply says, this guy gave you some object, you're holding on to it, play with it, that's fine, right? On the other hand, if you change this to B, now we have a problem because you don't have access to B directly because you never requested for it. Now, this can be a bit painful, isn't it? Let's see what we can do about this pain. So this is the handover method. So to understand this, let's go to this third implied readability. Let's open up all the Java files in here. Here's my second user. Second user says, I'm going to use first user. Hey, no problem. This is like the Jane and the Sarah's class. I get the first user. How do I use this stuff? Very simple. My package is called another. So I go to the module and say module com agile dot second. So second is my package, and I'm going to say exports. And what am I going to export from here? I'm going to export this another package. I got to do a requires com agile, and this is going to be the first. That's the module I'm going to bring in. So all this is fine so far, right? We brought that in. We're using first user. Everybody should be happy so far. So let's go back over here, compile all this stuff together, and run the code so far. Now, when I run this code, you can see it is going to compile all the code in the 3_implied readability, bundle up to a second.jar, and then just call it. So when I run this, hopefully it should all work just fine with no problems at all. So let's go ahead and say build.sh and see what it does. Well, there you go. You got the first user, no problem. However, now I go back to the code and say, hey, you go ahead and second user, go ahead and ask for Fibonacci from the first user's handover. This is exactly what we are doing, right? This here wants to reach over to this, but through this. In other words, we are doing this. What's going to happen now? I got the Fibonacci, and then I want to call the method on it. The short answer is no, you cannot do this because you're not really doing a handshake. You have no direct dependency on it. So when I compile this code, you get a compilation error. And the compilation error says, module Agile Developer second it cannot be used in this case. Here's the error. And it says, sorry, second does not read it. There are two ways to solve the problem. One way to solve the problem, not a very elegant way, is to go to the second and say, requires Agile Developer. This is a boring way to do it. If I go back and run the code this time, because I did a requires, that is perfectly fine, it worked. But that's kind of boring. Instead of doing it this way, why is this not a good idea? The reason is, I didn't really need it directly. I'm using it because first is giving it to me, and I'm using it through first. So rather than having to take this pain, there's another way to solve the problem. And that is, let's go to the module info, but this time we go to the module info of first. And here you say, I require Agile Developer, but I'm not going to require it for me. I'm going to require it for me and everyone that requires me. So I'm being generous here, right? I'm not only going to take it from you, but I'm going to take it from you and give it to everybody that is taking stuff from me too. And that you do by providing. Before I go further, I want to make sure I removed the other part. I thought I did. Yes, I did. Let's make sure the code fails before I fix that. And there it failed. Okay, now let's go back here and say requires, but this becomes transitive, right? So you're making it transitive. Transitive means I require this, but if anyone requires me, it's as if they required that one. So by making it transitive, you have now drawn a relationship from here all the way up to here automatically for this. So making this transitive draws this bridge, if you will, right? So now it's as if this guy has made a require on this particular object, and so as a result, that ties it down to that right now. So that dependency comes in. Let's see if that works. So go back and run this now, and you can see in this case, oops, did I save it? So that's going to be transitive. Oh, you know what? Wrong place, isn't it? It should be in the first, not in the second. I was sleeping at the wheel. Got hold of the wrong module file. So let's fix it. So I go to the other module file first. There we go. That's where I want it to be. So that's going to be transitive. So transitive. And now that we made it transitive, let's go back and run the code. And that's what we are doing, is going to bring the access to it. Okay, so we saw how to make this implied readability, right? So this implied readability simply gives a nice way to take your reads and make it available for the modules that require you. Let's talk about reflection and encapsulation. Encapsulation says you cannot use what's public. You can only use what is public and export it. Either export it to everybody or export it to the cousin, right? To the specific module. So you ask where it's being exported to. That's basically what you are asking for. So to do this, to understand this, let's go back to our code here in the Fibonacci class. The Fibonacci class returns, getHelper returns helper. But what is helper? Helper is my helper. Well, my helper is public, but my helper belongs to Impl, and Impl has not been exported. So for all practical purposes, my helper is hidden. you're not supposed to get to it. If you look at my helper, I have a method called hidden. When you call it, it says hidden method called. That's all we have right now. As a result, when I go to the first user, in the first user, I am going to get the helper, and then I'm going to print the method, then I'm going to invoke it, and you saw this earlier, it gave you an error. So it says, sorry, you cannot do this. So there are two things to keep in mind. The first thing to keep in mind is when a class is hidden, in this case, my helper is hidden, you cannot touch it at compile time, period. Sorry, end of story, go home. You cannot touch it, right? So if I want to use my helper, you cannot use my helper. Why? Because my helper is hidden. It's public, but the package has not been exported. So if I try to cast helper to my helper, I will get an error. Let's not even go here to the invoke yet. This is a compilation error. You fail at compile time, right? It says, no, you cannot do that. It failed at compile time. Let's go ahead and comment it out real quick and compile the code one more time to make sure it compiles, and you can see that it compiles now. So, moral of the story, you cannot touch it at compile time. But what about runtime? Hey, wouldn't this be cool? I'm going to say over here, class.forName, and I'm going to provide the name of the class to be able to get to it, right? So I'm going to ask it to get me the class. Well, what is it going to give you? It's going to give you a class over here. And this is going to be class that you get out of this. Well, but notice this is class, not your my helper. So you haven't really tied this to my helper still. This will still work. But I cannot still use it by the name. Well, if I cannot use it by the name, how do I call the methods on it, right? Well, here's an idea. I can go here and say, I have this thing called helper, so why don't I say helper.hidden? Well, not so fast. If you notice, helper, the interface helper has an add method. It is implemented by my helper. I can call add because add is visible through the interface. The implementation is going to run it. But hidden is not visible through the interface. The code won't even compile now, right? Because the code doesn't know what hidden is on the helper. The only way I can call hidden is to cast it to my helper. Timeout, I cannot cast it because I cannot touch it in the code compile time. All right. Because I cannot touch it during the code compile time, why not just sneak around, use reflection? Well, I cannot use reflection either because it's encapsulated. So when I run this code, the code compiles, but it fails during runtime. We saw this earlier. So that didn't work also. Where do we go from here? Well, let's step back and understand this. If you want access at compile time, exports the package. With me? If you export the package, what's going to happen? Then you get, if you exports, you get access at compile time and as a bonus at runtime. You may argue, what's the point in getting access at compile time if you cannot access it at runtime, right? So it makes sense. However, I don't want access at compile time. But I want access at runtime. Right? It's okay. I don't want to touch it during compile time. But I want access during runtime. Can you give me that? Yes. And the way you do this is you go back to the module info. There are two things you can do. In the module info, remember the impl was part of this, is part of this. I can say open. This will open every single package in your module for reflection access. That's what this does. If you put open up there. Don't do this too easily, right? Let's see if that works. So go back and run the build. And when you do, did you notice hidden method called? because you opened up access to it. I still cannot touch it during compile time, right? Because I didn't export it. So during compile time, my hands are tied, but during runtime, I can sneak in and get it. All right? One thing. No, but I don't want to do that. Why not? Because I have 7 packages as an example, and I don't want to export all the 7 packages. What do I do then? Well, then opens, and I'm going to say com agile developer.impl. So I'm opening just that one package for access only, not everything else. A quick note, please notice the word opens versus the word open, right? Little subtle difference. You're opening the module opens this package. That's why it's called opens, right? So just a little S in the end. This one is a little bit better than putting open at the module level. Much better is not to use it at all, right? So that's basically what you can see. Now that I removed all of that, what is going to happen? In this case, of course, if I don't open it, then we're going to get into a runtime error because that's no longer visible, and as a result, you get the error. So what did we learn in that part? What we learned in this part is reflection is closed, but you can get access to reflection by either opening a module or opens the package. So that's a little way to break through that. So far, so good, but I got a lot more to talk about. Let's talk about Service API, Service Load API. What is this about? Well, okay, so this all worked really well, but we want to really work with interfaces that are implemented by multiple different implementations. If you want to do that, how are you going to support this kind of operation? So to understand this, let's go to a slightly different example here. The example we want to go to, I'm going to make sure this is compiling now, okay? The example I want to go into is going to be this. In this example, I got a series of files I want to take a look at and understand. The first thing I want to show you here is something called rates. Let's take a look at rates. Rates is going to contain a module info, which is empty. Rates also contains over here, it also contains a class called interface called vendor.java. Vendor.java is a get name and a get rate. That's what I have here. Okay, that's an interface. This interface is in a separate module. What is the name of the module? I'm going to call it as com agile developer rates. So I'm going to say module com agile developer rates. This exports com agile developer rates, right? So I just kept the name same, not a big deal. So rates module is going to export rates, which means vendor is exported. Awesome so far. So we'll keep it that way. The next thing I want to do here is I have rate finder. So let's go ahead and look at the rate finder. And the rate finder also has a module info. We'll come back to that in a minute. But the rate finder also has the class called ratefinder.java. The ratefinder.java says, I am a rate finder, so I'm going to grab that, put it as a module name, rate finder. And what am I going to export? Exports ratefinder.that one. Now within the rate finder, I have a main function. It says query vendors. And I don't know about specific vendors. I don't want to depend on the specific vendors. It's a plugin architecture. Tomorrow you can throw in a new vendor, or you can get rid of the old vendor, right? I don't want to change any module and couple to it. So I'm going to find out how to get those vendors in just a few minutes. We'll just start with these baby steps. So, but one of the other things I need to do here is I'm going to say requires and com agile developer dot rates the module that I'm going to bring in. That way I can talk to vendors. Notice I need access to vendors after all here, that this guy, so I'm going to bring in the require. I don't have the specific modules yet, so we'll worry about it a little later on. Let's go ahead and do the build on this and see if it takes us anywhere at all. When I do the build on it, line number 2 is having a trouble on module info in rates. Let's go ahead and fix it. So this is module info in rates. Well, let's go ahead and fix it, -info. And this is under rates. There we go. So line number 2 is exports. There we go. So let's go ahead and try this again. So this is going to tell us, well, I have a thing called vendor 1 and vendor 2, and I've not really required those. It's choking up. That's okay. We'll fix it in just a minute by just removing the build, and we'll come back and add the build a little later on. So what I'm going to do is, let's just go ahead and comment out all of these. We'll slowly build this one step at a time. So what's the very first step? The first step is I want to compile my code for the rates. The second step I want to do is I want to compile all the way down here. I want to compile my rate finder. So let's go ahead and compile that also. So hopefully those two parts will work properly and produce no error. There we go. So, but I don't have any vendors yet. How am I going to bring a vendor? Well, the way I'm going to bring a vendor is, let's go to vendor 1. And in the vendor 1, here is my vendor1.java. Vendor 1 says I'm implementing vendor. I'm having a default constructor. And my default constructor simply says vendor1 created. So your constructor with no arguments. Then get name and get rate from the vendor. You know, obviously, to make this work, I need to require vendor, module with the vendor. So for that, I'm going to say this is my first vendor. So I'm going to go to module info, module vendor1. That's the name I give for it. And I'm going to say requires, and requires what? Requires comagile.rates. So that way I can get the vendor. Let's see if that works. So I'm going to go to the build file. Here is my vendor 1. I want to compile vendor 1 quietly. So when I compile vendor 1, now that I have included the build for it, it should be fairly happy, I would think. Let's make sure it's actually true. And requires. It actually helps me to type this properly. Let's do that. So here's my module info for the vendor 1 and requires. There we go. So try that again. So we compile vendor 1. Nothing really special in vendor 1 yet. We'll change that in a minute. Similarly, we go to vendor 2. Vendor 2 is a little different, just to show you an illustration of a difference. This is going to be module, and this is going to be comagile vendor 2, and this requires also the rates. However, let's look at vendor 2. Vendor 2 does not have a default constructor. Vendor 2 says, I got a Boolean preferred. But notice I have a static method called provider. So what Java is going to look for is either a constructor which takes no arguments. If a constructor doesn't exist like that, it looks for a method called provider. That's it. You don't have to implement any interfaces for that. It just looks for the word provider. It's a static method. Everything else is the same. So let's make sure this compiles too. So I go back now to my build file, and I'm going to compile this also. But when I run this code, it is going to be happy with all these dependencies. So compilation should pass, but how do I actually use this? Well, to understand how to use this, we need a few more details. The very first thing we need is a set of contracts. We're going to use inversion of control. Your code says, I need a vendor. Somebody's able to give it to you. Service loader has been around for a while in Java. That's been enhanced in Java 9. And so the service loader API says, you first of all uses X. What does that mean, uses X? Well, uses X simply says, if you go to the rates finder, in the rates finder, you have a module info. In here, you say uses Agile Developer rates.vendor. You tell me what interface you are using. So what does Java do? Java will come around and say, hey, I saw your dependency description, and you said uses vendor. That means you are a consumer of vendor. So when I find vendors, I'll give it to you, right? So that's why you said uses. Great. Now the second thing I do is I go to the edit vendor 1 module info, and here I'm going to say provides Agile Developer vendor 1. What is the name I gave for the vendor 1? Right here. Vendor 1 dot vendor 1 with provides that with Agile Developer rates.vendor. So, I'm sorry, the other way around. So this is providing this interface, vendor, with the class. With what class is it providing? with the vendor 1. So it provides that with that class. So this again tells Java, hey, I have an implementation in my module, you should know, and I'm implementing the vendor interface. So the wiring can happen now. So this is on this side. Similarly, I'm going to go ahead and edit in here vendor2.module.info, and I'm going to say right here, provides, but this is going to become vendor2, right? This is going to become, oops, where's that file? So this becomes vendor2. So let's revert. Okay. So this becomes provides. This is vendor with vendor2, and this is vendor2. Almost there, almost there. Let's make sure all this is working actually together. But we need to still know how to bring it in, but we'll do that in just a few minutes. So compile it, it's still happy. Now let's do some fun things. This is purely configuration. So what are the things we did? We said uses, we said provide. Uses interface, provide interface with that class implementation Y. Now I want to go to the service loader. In the service loader, I am going to now say, let's look at this guy. This is the beauty. Let's use the service loader to query all vendors. But before this, I say service loader vendor vendors1 is equal to service loader.load vendor.class. Here comes the charm. This does not create any objects. It is lazy evaluation. So at this point, notice I just said load. It did not expend any effort to create these objects. So when you look at the output, it still says querying for all vendors. Then I say for vendor coming from vendors 1, and what am I going to do here? Output. And output, what am I going to output at this point? Vendor.getName. And similarly, I can call vendor.getPrice or getRate, not a big deal. So when I run this now, what does it do? Now notice in this example, it printed this, and only then it created vendor 2, printed vendor 2, only then it created vendor 1, printed vendor 1. That's how lazy it is. Right? So we can get these things. You say, no, I don't want all the vendors. There are several vendors, but I want to cherry pick the one I want right now. Vendor with a certain flavor. How do I do that? Well, you can do that very easily also. To do that, let's get rid of this. We can say vendors 1 again, but this time what I'm going to do is I'm going to call upon vendors1.stream. This gives me a provider. So I can say .filter, given a provider, I can say provider.type. This gives you a class, the big C class. Once you get a class, you can query whatever you want to query on the class. You can query for name, query for patterns, query for annotations. You can do any kind of query on it. So if you know your own annotations you have created, you can see if that vendor or that particular implementer implements that particular annotation. I'm not going to work with annotation here. So instead, I'm going to say contains, and I'm going to look for the word to. So in this case, I'm going to say, if you have a to, then I want to talk to you, not otherwise. So then what am I going to do? .map. I take the provider given to me and return provider.get. This is going to create an object. Then I say for each. This is going to be my vendor, and I'm going to output, what am I going to output? A vendor.name. So vendor.name, get name, right? So you can query for things, and you can use the provider and get things also. So when I go back and run this now, let's see what it's going to tell us. In this case, that's not good. So it gave us an error on type, get name, isn't it? So type.getName, so because it's a class. And then do the other work. So let's see if that works. So what am I going to do in this case? I get, in this case, if it has to, vendor 2 created, not vendor 1, because vendor 2 is the one with the word to, not vendor 1. So this gives you an idea about how you can use a service loader API. The reload is for you to recreate all your objects. So you can say, give me a new fresh objects also, and you can load it. So it's a very slow, or not slow, but a lazy evaluation, which is good. I will have 3 more topics I want to talk about in this area. Well, the next is something really charming, which is a linking custom runtime images. I want to remind you one thing, one more time. When you go back and say Java --list modules, remember that? We had 94 modules. Keep that in mind. Well, good news, they are modularized. Bad news, they are still there. And whether you want Corba or not, it is just sitting there, right? And sometimes it annoys you. It's like, go away. I'm never going to use you, right? So what can we do? Well, here's an idea. Let's go back to one more example. In this example, this is purely about linking, nothing to do with compiling. So I've compiled the code, I've produced the modules already, and they're sitting happily in a directory. What can I do? Well, this one here is purely about building. I blow away the Agile Developer directory in this directory. I use a program called JLink. JLink, where is all the modules for Java, where is all my modules, and then add modules Agile Developer and add modules Agile Developer.first and output to Agile Developer and give me a launch name called Agile Developer. What does this do? What does this JLink do? Let's only run up to this part right here, not anymore. So when I go back and run this part alone, notice what just happened. Well, before I go any further, this directory had only the build. Now I go run that. Now this directory contains the build and the Agile Developer. Go into Agile Developer. There is a bin directory. Go into bin, and beautifully you see Java. This is not any Java. It is my Java. It is my precious, right? And you can ask this Java, what do you have? List modules. Word count minus L. 94? No. 3. I contain only stuff I need, right? So this creates a very targeted custom image. In fact, if you ever said, I really miss running programs with clearly defined my own names, that's your named program. Welcome to C programming, right? So you can create dedicated executables too moving forward, right? And that dedicated executable is just a binary created. That's your Java, your precious. And as a result, you can create a very small customized distribution. And imagine you don't have to install the whole boatload of stuff on your systems. You can spin up your servers with minimally things you care about and nothing else. If you want to put this on devices, if you want to put this on whatever that you want to put it on, you're just loading essentially what you care about and nothing else at all. That's your custom image using JLink, as you can see right here. So JLink can create the target image, and then you're able to run it either by the application name or able to run it as Java also, and you can look at the list mods pretty nicely. And with that said, how do we go from where we are to over there? Well, to go there from where we are, we want to talk about transitioning. I'm going to talk about a couple of different transitioning techniques. The first is, I have nothing to do with Java 9. I have Java 8. I'm happily running it. I don't want to really do anything with Java 9 right now, but I just want to deploy it and see how it runs. What you could do is one thing. You could take your jars and put them into class path, like you do, run in class path. Just like the old way of doing things. No mention of module path. Java, run Java 9, put in the class path, what happens? it runs like the way it runs. And when it does, those classes belong to what is called unnamed module. Remember how when you don't put a package, it gets a default package? It's the same similar thing. When you don't give a module name, it becomes an unnamed module. When you're an unnamed module, everything lives in this unnamed module. And they're all happily sitting there and working. And it works like the old stuff. Not a big deal. So you can still do that. That's an initial transition period. I can continue to run with Java 9 and move forward. But I want to recompile my code. I want to use modules. I want to get ready for this stuff. How do I do that? Well, for that, we are going to talk about how do we transition from the old to the new. And to do this, let's say this is Venkat's module. And Venkat's module depends on, let's say, over here is Sarah's module. Well, there are a couple of problems. Venkat wants to change it to Java 9. It's like, go for Java 9, go for Java 9. I want to change it. Sarah says, hold your horses. I'm not ready yet. Why? Because two reasons. Sarah says, not now, no time. Or Sarah says, you know what? I love this change. I'm going to make a disruptive change, which is not helping me. So these are two options, right? A disruptive change or no change. So we'll talk about both of these. One is no change, not now, and the other is disruptive change. If Sarah doesn't change anything, then I still want to use the old jar right now in my Java 9. If Sarah disruptively changes things, I'm like, I'm sorry, I don't have time to make all the code changes to use your new version. Sarah, thank you. I'm going to move to Java 9, but I would rather use your old jar. Sorry, I know you're supporting Java 9, but I'm not ready to use your version. I don't have time to change to all your disruptions. So in both cases, I want to use Java 8, Java 7 module. We'll call it as old jar, right? Jar, not the module. This is module. How do you deal with this? Good news. You put Venkat's module and Sarah's, sorry, not module, right? Jar. Sarah's jar, both of those into the module path. Just take the old jar and dump it into module path. Venkat's module comes to life and says, hello, I'm a module. Here's my module info. And Java says, awesome, come on over. What do you want? In my module info, what am I going to do? Requires Sarah, right, jar. I'm going to specify that. And Java says, Sarah jar, let me check. It goes to the module path and says, oh, there it is. But this is old stuff. It doesn't have a module info. No worries. I'll use your jar name as your module name. That is called automatic moduling. Automatic moduling is your jar name becomes your module name, almost. If my module is called foo.jar, sorry, if my jar is called foo.jar, what's my module name? Foo. If my module name, jar name is foo-all.jar, then what is my name? Foo.all. The dash becomes a dot automatically. If my module jar name is foo-all.1.2.3.7.jar, what does that become? Foo.all, period. The numbers are ignored. So this is the automatic moduling. Or you say, hey, Sarah, I know you have a new module. I'm not ready to use it. But your new module has a completely different name. You gave a new name in your Java 9 module. You know what? And that is not Sarah jar. If I use Sarah jar, when I decide to use your Java 9 module, I got to go change my code. So could you do me a favor? You open up your old jar, go to manifest, put an entry for automatic naming, and use the name you will use in the future. And that way, I can be safe that when I swap your jar with the module, my code will still work. So one recommendation is, if you're not ready to build for Java 9 yet, you might want to at least change your manifest file and give an automatic name. If your jar does not have an automatic name in the manifest, then Java will give one for you. If you give a name in the manifest, Java will use that name. It's better that you give a name than Java give a name for your jar. And that's how that's going to work. And so finally, you can just throw that in there and things will come to life and be able to support you. And that is one of the biggest benefits you get out of it. So to summarize what we talked about, Java 9, I think, is incredible in terms of its power. By far, it is probably the best set of changes in the language, the most significant. In this talk, I divided this into 3 parts. I talked about what I like to call as improvements and changes, what I like to call as additions, and as advances. In the improvements, we saw several things that are making our lives better from Java 7 and Java 8. In additions, we saw new things we can do, including REPL and list off and a few other things, including the callable futures, completable futures things. In advances, we pretty much focused on the modularization itself. So it's definitely a lot of fun. It's going to be a bigger learning curve and effort as we transition, but overall, it's also a very powerful change as well that will come back to benefit also. And so overall, I'm very positive for what's really happening in this area. I hope you found that useful. And if you want to download the code examples, by tomorrow morning, I'll post that on my downloads link. You can download and play with the examples. Thanks for coming.